Ik zou zeggen, een warm welkom voor Peter Lyngdorf.
The major issue today with quality of music is the dynamic range compression issues, or the loudness, or as we call it. PLR is something you'll learn about the next few years. It stands for, or it's an acronym for peak to loudness ratio. Some people call that dynamic range. It's an indicator of the dynamic range, but the correct way to express this is by peak to loudness. Loudness is kind of the average level of a piece of music or whatever source material, and peak is then the maximum peak. So from the average to the maximum peak is what we call peak to loudness. There's a guy called Ortner who has analyzed 10,000 pop songs from 63 to 2011 and checked the peak to loudness ratio, or more or less the dynamic range. And this is what it looks like. From 63 to 84, actually a pretty good increase of quality, up to just over 16 decibels on average. And this is for pop music. And pop music producers always try to make it quite loud, because you have the jukeboxes in the USA, you have the radio stations, everybody wants to be quite loud. But still we have about 16 decibels, which is in terms of voltage 1 to 40 between the peak and the average. So think of it as if you have an amplifier, a 10 watt amplifier, peak power would be 400 watts, right? So in those days it was important to have an amplifier with a lot of headroom. You didn't need a lot of steady state power. NAD, power envelope, I was involved in that. We really needed as much headroom as we could get. But what happened in 84 or after 84? Oy. 93, 96, that was when they applied digital compression, and they could then compress more effectively. So what this means is that from 84 until 2011, the quality has dropped. And actually in 2011, it was considerably worse than it was in 1951, on average with 78 RPM shell-like units. So this is what we are hearing today, unfortunately, on pop music. To have a song that sounds good and open and without too many compression artifacts, you need at least 12 dB peak to loudness. With extremely careful production, for instance, Daft Punk, Get Lucky, you know that track?
Yeah.
Popular track, sounds pretty good. It's completely same level all the time. That has about 9 dB and still sounds pleasant. It sounds very boring when you listen to it a few times, because there is really no variation to the dynamics in the song. But it can be made to sound pleasant with about 9 dB, which that one has. But it took a heck of a lot of work to make it so loud without making it sound nasty. Bob Ludwig, who did the mastering, we talked to him about whether he did a different mastering for the LP and for the CD. It's the same mastering, by the way. But it was a hell of a lot of work to get it so loud without making it sound nasty. So a typical example of engineers spending a lot of time making it as loud as possible and actually spending more time on that than ensuring a really, really good sound in the first place. What has happened, unfortunately, is that radio stations decided a few years ago that nobody needs more than 12 dB. So anything that is more than 12 dB, better quality than 12 dB, we just cut down to size. Then a few years later, they thought, what the hell? Let nobody hear what dire straits sounded like a few years back. We limited to 8 decibels. And a lot are actually down to 6 decibels, which means hyper-compressed everything. Stupid thing is that web-based radio stations all compress also. And the reason for that is that they want to be louder than the next internet station. But for sure they don't get greater coverage if they turn up the volume, as they did in the old days with the FM stations. You know, it will still go from Sydney to Amsterdam, right? Doesn't depend on level, but they're still compressing. I have a listening example of one of the worst artifacts that comes with hypercompression, with dynamic range compression. It's Anastasia. Anybody knows Anastasia?
Yeah.
Anybody loves sound?
No.
Okay. Good. Then we're getting somewhere. This is the CD quality. You know, it's interesting for a lot of teenagers. When you think about it, a lot of these young folks, they have never heard how good a CD can sound. They've never heard, because they've only listened to something not as bad as this, but sometimes quite bad. Right? So compression, there's dynamic range compression, which in my opinion is the worst kind of compression, and there is digital number crunching, where you use MP3 files and so on to save on the data. So there's dynamic reduction and there's a data reduction. It's actually two different things. And it's important to keep those separate, because a lot of consumers think when you say compressed files, they think MP3. But MP3 can have just as good dynamic range as a CD. So there are two kinds of compression. There's a dynamic range compression, and then there is the data reduction. If we use a picture to indicate what is dynamic range compression, it really means taking everything up to maximum. So this is how Mona Lisa would look if we used it on a picture. All the details at the lower levels disappear. And then there's a data reduction, which just takes away some of the details. And then you have the combination of the two, where you can practically not see what the heck, or hear what the heck is going on. Now don't really want to, but I will play you some different tracks from this dark ages, some of the examples of really badly compressed music. And you will see a loudness meter, which indicates the loudness of the tracks. And you can see from the DU meters, the round scale, that the music has virtually zero dynamic range. It's just a steady stream of noise. We're comparing to a Vest, that's a Danish band. I don't know if it's a band or not. You can't hear from the recordings. But they present themselves as a band. We have Max Nilfisk, and that is actually Nilfisk, the vacuum cleaner, at maximum level. I wanted to check, because you know, if you have a vacuum cleaner and record that and keep it absolutely quiet, that must be the most steady state without dynamic range kind of sound you can imagine. And it's actually sounding very sweet compared to the music. Kelly Clarkson, Metallica. That Metallica is from Death Magnetic.
Yeah.
You know that album?
Oh yeah.
it came out first on Guitar Hero, and everybody cheered and said, "Oh, it sounds pretty good." But then when they released the CD, they compressed 10 dB out of the dynamic range, so it sounds like shite. So everybody who pays for the music to keep get shit, but if you buy it for the game, it sounds a lot better. Okay? And finally, we have pink noise, which is basically all tones, full blast, all the time, just to see how loud is that compared to the music. Because you shouldn't be able to get much louder than every single tone all the time, right? But yes, you are. If you work hard enough to destroy the music. Metallica is 6 dB louder, 4 times louder than all tones at all time at full blast. Think about that. It is quite an achievement. And they actually spend so much time to make it so loud rather than spending a lot of time making it sound better. So I'm trying to promote to the record industry the idea that people actually have a volume control. If they want it louder, they can turn it a little bit to the right. If they want softer, they can turn it a little bit to the left. So for everybody who has a volume control, there's no need to compress music to make it louder, because that's what we use a volume control for. But of course the problem is they want louder than everybody else. Now there is a very good chance that loudness normalization is going to be the norm. YouTube has implemented it. Spotify has implemented Tidal. We are working with Tidal about the best possible implementation. We hope that they're going to do something that's pretty advanced. So it's going to be really helpful both for mobile and for domestic use and so on. So once everybody becomes normalized, they don't benefit anymore of compression. Because you're not going to sound louder when you're compressing music. You're just going to sound shittier. So we've gotten some traction with record labels now saying that, you know, if you have a good artist, in today's world you probably still need to compress because you have to be loud, but make a copy please that is ready for the future, because we are probably going to have a future where everything's going to be normalized. So make your good version now, because once you've hyper compressed the track, you cannot go back. You cannot uncompress it. There is no way you can make sense of that Metallica track again and find the guitar and find the kick drum and so on, because it's all mashed together. So what you can do here is you can take your digital files, WAV files. You cannot use FLAC files yet. But we're working on that. You simply take a file, drag it into the window, and your browser will analyze the file. Everything happens in your browser. We don't copy the music or anything, so this is totally legal. So this is dice rates, private investigations. You know that track, the original? Sounds awesome, right?
Yep.
Has fantastic dynamic range. So you get the data here. Sorry about the resolution of the screen. True peak, minus 1 dB. Nothing goes above 0. Perfect. Don't get any problems with the DC converter. Loudest, minus 24 dB. Peak to loudness, 23.6. A very good indicator of quality. And does that track sound good? You'll find it when you get home and listen once more. And it's an awesome track. But of course, we also have something from the horror cabinet. Johnny Cash, Hurt. You know that track? Everybody knows that track. You see, it starts really nice. Towards the end, they actually did not leave enough headroom for the song. So towards the end, it's heavily, heavily compressed. And towards the end, it sounds not good. In the beginning, it sounds awesome. If they had kept the track 5 decibels less loud, it would have sounded fantastic. And there is absolutely no reason for it to be compressed like that. There's a lot of voice and other some instruments, bass guitar and so on, that can sound fuller, nicer with an amount of compression. What we are opposed to is to make compression just to make things louder, because that's where I always say we have a volume control. There's 1 billion people in the world that has a volume control. Many more people have a volume control than people that don't have a volume control. So don't make it loud for us. We'll turn it up, we'll turn it down. So don't do compression for loudness. Take a kick drum. It has a fundamental with the maximum level. And let's say it's a lowly tuned, at a low frequency kick drum, let's say 40 Hertz. And it peaks at 0 dB. In digital, you cannot go above 0 dB. It's absolutely limit. So you record it like that, but then the producer wants to have the kick drum 16 decibels louder, but with the same tonal balance. 16 decibels, but you're actually at 0 dB already. How do you get 16 decibels more sound out of that kick drum? Yeah, you can say that, but really that's what we have. To make the 40 Hertz sound louder, what can you do if you don't turn up the volume?
You take down the rest.
You actually take one more, right? Then you have twice as much sound. Then you take one more, you have 3 times more sound. But 16 decibels, that's 40 times more sound. You want 40 times more sound out of it. So instead of having one cycle at 40 Hertz, you have 40. How long time does that take? 1 second. When is the next beat? In 0.8 seconds. So what happened to that beat? It was gone, right? Because you just have a long instead of the kick from a kick drum. What happens to the overtones? You have a fundamental at 40 Hertz. That one is actually delayed. It will last 1 second. So the delay is half a second on average for the fundamental. But let's see the overtones at 2 kilohertz. You also need 40 of those. But at 2 kilohertz, that's only 1/50th of a second. So the delay at high frequencies is much less than the delay at low frequencies. So all of a sudden you don't have a connection between your fundamentals and your overtones.
Yeah.
So you don't hear a bass guitar anymore. You just hear some blah, 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 blah in the bass and some overtones, and they're not correlated anymore. So that is one of the big issues about dynamic range compression. And that's why today in a lot of pop recordings, think about when did you last hear a range shot clearly standing out on a modern recording? Never, because they don't allow that peak to stick out. When did you hear a real bass guitar? Sometimes between something on a track. But when the musicians are playing, you don't hear the bass guitar. You hear some boom, 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 but you don't hear bass guitar. You don't hear the plucking of the bass anymore, because there is no dynamic range to show that.
Ik sta hier met Peter Lyngdorf op het Nordic Dynamic event. En Peter heeft net een hele presentatie gedaan over dynamieke muziek. And let's switch to English right now. I just saw your presentation and it seems like you're pretty pissed off at the music market right now because of all the dynamic compression.
Yes.
How did it get started actually?
My project or dynamic range compression?
Well, no, the Nordic Dynamic.
The Nordic Dynamic.
Yeah.
Well, it was born out of my frustration with basically the music industry and the fact that they have compressed dynamic range out of the music over the last few years. It actually has happened over the last 20 years that gradually less and less dynamic range has been left in the music.
Yeah.
And for no good reason whatsoever.
No.
Except that everybody wants their song to be a little bit louder than everybody else's song. And who is suffering is everybody who buys music.
Yeah.
And which, by the way, is not so many anymore. And I believe one of the reasons is
maybe because it sounds crappy.
It doesn't sound as good as it used to.
Yeah.
So a CD nowadays for pop music is not an investment, not something you sit down and enjoy as much as you did before.
No.
So I hope we can convince the music industry to at least make available a version of good songs that has less dynamic range compression for those guys and ladies who want to listen to the full dynamic range.
And from what I've understood is that you are actually talking to the music industry about this, and you found some, record labels that are willing to do that.
Yes.
That's
right now it's mainly in the jazz and classical, but we have a couple of good pop artists from Denmark now that have committed to releasing some new albums in Nordic dynamic version, so that the normal thing that will be sent to Spotify and the streaming services and to iTunes and so on will be a relatively normal compressed, but people can get from download a relatively uncompressed, much higher quality version of it.
Yeah, cool. And have you set a goal? What are you working towards?
Well, I hope, of course, we get as many musicians as possible to join this and get into making recordings with full dynamic range again. The interesting thing is that what we discovered working with the artists is that it cost maybe 2,000 or 3,000 euros to make two versions. The highly dynamic version, which sounds great at home on a big pair of speakers, and then the normal version. So it's really very little money. And now that we can distribute and sell music over the internet, it is really a no-brainer.
You can just download the nice one and maybe the extra one for in the car or something.
And even if the labels want, they can charge a little bit more for the nicer one. Sell it at 96 kilohertz, 24 bits. Also charge a little bit more for that, and customers are more than willing to pay for good quality.
Because that was actually an interesting part you were talking about. It was Simon and Garfunkel.
Yeah.
I know both albums, the normal CD and the high-res version. And actually, I didn't think the high-res version was that bad. But there is a difference.
There is a difference.
And you have a tool online now?
Yes.
Audio tester or music tester?
Musictester.net.
Yeah.
Musictester.net.
That can check the dynamic range in a song.
Yes.
That's nice.
So you put your file into the window, and it is actually your browser doing the analysis.
Yeah.
And you can see how a track behaves.
Yeah.
And you will find that things with greater dynamic range is typically also the ones. The tracks you really like to turn up the volume, play a little bit louder, and enjoy it at home.
Okay. Well, thank you for your insights in music dynamics, and I hope your struggle towards more dynamics will succeed.
Me too.
Yes.
Thank you.